In the BBC article, James Webb Space Telescope, Everything is Hunky-Dory, JWST has a primary mirror at 21.3 feet in diameter with a sun shield the size of a tennis court. Launched into orbit by the Ariane 5 rocket, the size of the mirrors allow the telescope to capture more light from distant and dim targets for a more clear image.
Oh, look here. We found a red-shifted galaxy with longer wavelengths similar to infrared wavelengths and in amplitude. The James Webb Telescope can determine the speed and direction of this galaxy. Using this information, we can also determine that because the wavelengths are more stretched out, the galaxy is moving away from us. On the other hand, our blue shifted galaxy is moving towards us, which then shortened the wavelengths that it was emitting into the blue wavelengths of visible light.
Alright, so now we're going to give a brief history on the James Webb Telescope. The James Webb Telescope is a successor to the Hubble telescope that was launched in 1990. Right after the Hubble scope was launched, NASA proposed in 1989 that they need a new generation telescope that was needed for more in-depth and precise imaging. In 2002, the telescope was named after James E. Webb, who was a former administrator of NASA. In 2004, construction began on parts that required extensive engineering, like the 18 segments of its mirrors. In 2011, the mirrors were completed. In 2013, two final instruments made, the near-infrared camera and the near-infrared spectrograph. Both of these instruments allowed the James Webb Telescope to view our universe in the infrared realm. In 2019, the James Webb Telescope's sun shield is completed and engineers successfully connect the two halves of the James Webb Telescope together. In 2021, the James Webb Telescope is folded and stowed for launch. And finally, on December 25th, 2021, the James Webb Telescope is launched at 7:20 a.m. on the Ariane 5 rocket from Europe's spaceport in French Guiana, South America. Now for a little bit of, background on a major field that the James Webb Telescope has been studying. One field that's been focusing on is the look for distant galaxies. The James Webb Telescope is so powerful that it has found red-shifted galaxies at astonishing redshifts of 10, 11, and even 17. To put this into perspective, a redshift of 1 corresponds to 6 billion years after the Big Bang. The further you go up the scale, the further you go back in time. James Webb Telescope was able to detect a galaxy of redshift 17, which means that it was formed 225 million years after the Big Bang.
Oh my God, it's a blue star. I wonder how long the light waves are on this one. Oh my God, it's coming towards us.